are ready to present.
Yes, sir. Good evening.
Or good evening. If you are
Okay.
ready, you can share your screen. You can start your presentation.
Okay, Doctor.
Please, you have 10 minutes.
Okay. Can I start it?
Yes.
Okay. Our research paper is titled Enhancing Smart Grid Stability with the Implementation of Heuristic Algorithm by Qatada Jihad Abdul Qadir and Mishhan Ghazi Abdulaziz under supervision of Dr. Zaid Hamoudat, Electric and Computer Engineering at Tubash University. Agenda, production, objective, related work, significance of DSM on SG sensibility, challenge of DSM implementation, conclusion. Introduction. As a consequence of rise in power use and the security of renewable energy source, the energy sector is experiencing considerable challenge. If the current can't continue, the traditional grid will be unable to keep up with the unexpected increases in energy use. In the present electric power system, an intelligent grid is being implemented with employs two-way communication to prioritize energy use and regulated demand in order to increase efficiency. Using a smart grid technology such as electricity distribution and enhanced demand-side management (DSM), distributed generating becomes economically feasible (BDN). The decreases of peak output is an essential element to consider the capacity to control energy use, reduce the maximum load. By decreasing peak demand using DSM both to utility and the customer of saving money and save time. The additional of commercial energy management is major academic discipline across the globe due to the substantial impact of domestic applications of overgrid energy consumption. This pictures of distributed energy of photovoltaic hybrid electric vehicle. Objectives. The fundamental goal of the optimization technique is to improve energy management. The study suggests installing a GA-based home energy management system in order to better control household energy use. This article provides a detailed examination of the effectiveness of large array of well-known heuristic algorithms. Related work. The other employ a real-time pricing model RTPM to investigate to scheduling of household appliance RTP. This study provides information of residential energy use in order to strike a compromise between the radiation of expenses and oils generated by both terminal and electric equipment and the maintenance of high degree of comfort. It was also considered whether of the note prices variable over the year. There's many related work here, but time is very shortly. Significance of DSM on SG sustainability, a possible influence of an investment in SG on the power infrastructure of the 21st century is good one. The SG has been a popular alternative among engineers because to it is distributed generating self-healing capabilities, digital two-way communications, and universal control. Challenge of DSM implementation. When it comes to load scheduling, DSM algorithms are essentially susceptible to distribution by adversaries with may readily introduce multi-cost data into control system. This respective information encourages to energy provider to project the customers like limit demand resulting in increases energy price. Conclusion. They evaluate the effectiveness of different optimization methods in terms of energy consumption, PAR, and total cost of electric power generation. We use a number of optimization techniques as seen by the applied data all system with the expressions of the BPSO based HEM used less energy than the grid demands. This is a helpful development. The constant energy using of WDO maintenance user comfort while decreasing total costs. As seen by the statistics, the maximum light intensity is new less than what was provisionally visible. Georgia-based HEM baits rivals in terms of average bill decreases and customer satisfaction on advantage of HEM based on BPSO technology is that is reduce power costs. Non-utilized use expertise and productivity are two disadvantage of the technology. GI-based HEM surfaces other optimization strategies with response to achieving the intended outcomes. Thank you very much.
Thank you for your presentation. Dear participant, do you have any question about the paper? Okay, no question. Thank you again. I wish you success, dear Kota Jihad Abdul Qadir.
Thank you very much for your listening. Thank you very much.
Okay. Dear Remzi Qasim Mohammed are ready to present.
Hello. Yes.
Okay. If you are ready, you can start your presentation.
I am ready. Can you cancel screen?
Can you share your screen?
Hello and good evening. I introduce my presentation entitled Optimal Voltage Stability from SCADA Acid Solar Area and Using ACO Logarithm. Abstract. This paper presents recent research on PVDG allocation is reviewed from two. Number one, the DG itself, including optimization, methodology, and objective. Number two, the methodology from estimating PV potential. As a result of this review, holes in the previous research were discovered and novel strategy was developed to address them. The authorities are certain that their effort will be contributed to resolving the power system difficulties. Additionally, it adds to the expansion of solar energy use in the poor nations. Page number 2, introduction. The nation law are regulations also limit the amount of potential energy that solar energy can be generated. These results are reviewed in light of current PVDG research in the power system, transmission and distribution system, including optimization approaches, constraints, and obstacles and objective function. The ACO based optimized methodology provide optimal power extraction from solar and wind energy source from residential application, which contain high convergence, velocity, surge performance, and simple implementation major advantage. Page number 3. What is the PVDG? Photovoltaic distributed generation, PVDG. It's the most popular used clean source investigating the most suitable location and size of PVDG. Her power system improved optimization algorithm and system objective with PVDG have significant role. This work review some present studies of PVDG in power system, transmission and distribution system, including optimization, logarithm constraints, challenge and objective functions. In addition, it is include the exciting work for sustainable PV resource potential assessment. Such work will help to find the gap among relative conducted studies and propose when new methodology authorized. Strongly believe that power system capability and PV resource potential assessment should be considered at some time optimally. Page number 4. What is the ACO logarithm? Anti-colony optimization logarithm is a class of optimization logarithm modeled on the action of an anti-colony artificial ants. Example, simulation agnets, location, optimal solution by moving through a parameter, a space represented, all possible solution rail and lie down ferment directly. Each other, the resource will exploring their environment, this simulated ants. Similarly, record their position and the quality of their solution so that his later simulation iteration more and locate better solution. On variation on this approach is the P logarithm, which the more analogs to the foregoing patterns of the honeybee, another social insect. Page number 5. High PV penetration present a number of challenges. Point, estimate the peak PV power of the feed by multiple the number of customers connected to it by estimate of the feeder peak PV power multiplied by the number of loads connected to it. Point, the effect of photovoltaic on voltage regulation, the danger of overvoltage 1 to the earth fault, and the possibility of islanding, where feeding have light load are all included in the application, their principles. Point. Numerous studies have shown varying percentage of the household with high solar electricity penetration. A point. Increase in solar PV penetration level beyond 15% being to highlight the problem associated with high solar PV penetration levels. Nevertheless, there is no published standard for identify the specific percentage of solar PV penetration that define a high PV penetration level. Number 6, challenge of high PV penetration in the future. Number 1, the future effect of plug-in hybrid electricity vehicles. Number 2, sites that are involved are those that. Number 3, solar photovoltaic PV. On-grid distribution generation DG with photovoltaic PV impact. Number 1, optimization of PV DG without use the solar energy is highly reliant on range parameter including weather conditions, power converter design and control method employed. Number 2, the voltage is increased as a result power supply was not intended and handle significant quantity of PV-DG energy. Number 3, the quantity of PV-DG synthesis varies significantly. PV-DG output varies because to the intermediate neutral of the sun's irradiance and temperature. And finally, page number 7. PV-DG with improved performance. 1. Below is the voltage curve with optimal PV-DG ratio. Number 2, it is peak the power factor of the PV-DG system generates actual energy with power factor of unity, which increasing the likelihood of voltage spikes and deterioration in the power factor of the electricity. Number 3, voltage sag, the last when the ideal PV-DG ratio is employed. Number 4, the degree to which perfect PV-DG generates volatility. Conclusion. The research result classify the rival risks related with photovoltaic interconnected network according to their effect on the network in light of the product growth and photovoltaic penetration. This report also examined variety of the alternative future scenarios and their ramification for entire network. The current state to us of the technology's solution and their current level penetration were also extensively explored. According to the finding of the study, there is much room for improvement. A number of the solution now is unused. According to the pool finding, the associated with PV integrated network are still there, FNC, and will become more obvious penetration develops practically in light of the future scenarios mentioned before. Thank you.
Thank you for your presentation.
Thank you for listening.
Participant, do you have any question about the paper? Okay, no questions. Thank you again. I wish you success in your study.
Thank you very much for listening.
Dear Saman Kanzi, are you ready to present?
Ramzi
Hello.
Qasim
Yes,
Mohammed.
I'm ready.
Okay.
Can you hear
If
me?
you are ready, you can. Yes.
Okay.
You can share your screen.
Sure.
You can start your presentation. You have 10 minutes, please.
Can you see my screen?
Yes.
Okay. Hello, everyone. Welcome to my present. Sorry. Sorry, can you see my screen? Hello.
Not yet. Not yet.
What about now?
Yes.
Okay. Sorry for my delay. Hello, everyone. Welcome to my presentation on multi-objective optimization technique for optimum allocation of DG in distribution systems using weight factors. My name is Saman Kanzi. Thank you for attending. The present paper, while attempting a solution in this direction, formulates the DG placement problem as a multi-objective optimization problem consisting of power losses and voltage deviation as the objectives to minimize. The multi-objective optimization problem is solved using genetic algorithm. This presentation includes 5 sections: introduction, literature review, methodology, and results. And of course, I will summarize my thesis as a conclusion. Introduction. In terms of its capacity to use alternative energy sources, distribution generation, or we call it DG, offers a bright future for power generating in electric networks. The contribution of distributed generators to power systems ranges from increased energy efficiency and power quality to increased dependability and security. This advantage can only be realized if distributed resources are optimally located, taking into account the objective function, restrictions, and a suitable optimization methodology. In this study, a comprehensive review on the optimal allocation of distributed generators was carried out. The result will illustrate how the methods and algorithms for optimal distributed generation allocation play an essential role in improving the accuracy and efficiency. Distributed generation definition. Distributed generation is defined as an electric power source that is connected directly to the distribution network or to the metering site of the customer. The table shows different generation of DG at different levels. Literature review. Among the research which studied optimal distributed generation allocation, some purely focused on voltage profile or voltage stability improvement as the optimization objective, while most of them consider loss reduction, including voltage deviation, along with the voltage profile improvement. Also, there is many researchers have used genetic algorithm to study issues related to power systems. In some studies, for example, by using GIA program and MATLAB, have obtained the optimum location and penetration level of DG units in order to decrease the losses and enhance the voltage profile of a power system. In another study, for example, GA is incorporated into a power flow study to search the optimal tap setting in order to minimize power losses. The multi-objective optimization problem is solved by using genetic algorithm. The reason, actually, the reason for selecting GA is that the problem is combinatorial in nature, and GA is perhaps the mostly used general purpose optimization technique to solve such these problems. GA algorithm is easy to implement, computationally simple, and always producing high quality solutions. The figure shows the some advantage and disadvantage of different algorithms. Methodology. Basically, backward-forward sweep involves two computation processes at each iteration. The backward process involves the power or current flow solution starting from the branch of the end buses, moving toward the branch connected to the reference bus. The forward sweep calculates the voltage at each bus starting from the reference bus to the end buses. During the backward sweep, the voltage is held constant, and during the forward sweep, the current or power value is held constant. The flow chart gives the actually detailed operation of the power flow calculation using backward-forward sweeping algorithm. Optimization. The optimal setting and sizing problems of distributed generation are formulated as a multi-objective constraint optimization problem. In this work, we use GA algorithm for solving the problems of optimal setting and sizing of DG. And the result will compare with PSO algorithm. Voltage deviation. Voltage deviation is also required for the objective function calculation to inspect the DG's utilization influence on the network. According to the assumptions, the voltage of a slack bus is always constant. It is let off in voltage deviation calculation. The voltage deviation is computed by dividing the total absolute difference of bus voltage, as you can see in the equation, except a slack bus from 1 by the total number of buses minus 1. And of course, we should drop a slack bus out. By this method, the final calculated voltage deviation value will almost be independent from the size of the network. Objective indices. The power flow and voltage deviation are calculated to form the objective indices. The active and reactive power losses indices are represented by IPL and IQL, respectively. In addition, IV deviation shows the voltage deviation index. These index computations are based on the original network load flow outcomes, which are governed by the following equation, as you can see in the slide. Where PLN, QLN, and V deviation and represent the active and reactive power losses, as well as voltage deviation for DG installation on the distribution bus of the network. Weight factors calculation. The obtained objective indices in the last section are employed to calculate the weight factors. These weight factors have reverse proportion with the mean value of their related indices. The employed method provides the weight factors an equal opportunity to affect the objective function results and makes them unified and dimensionless. Consequently, the smallest objective value is linked to the largest weight factor to give that objective equal chance in comparison to the bigger objective to affect the objective function. Objective function. The objective function is calculated using objective indices and weight factors as follows, as you can see in the equation, where IPL, IQL, and with deviation represent the active and reactive power losses, and voltage deviation indices. WP, WQ, and WV are the weight factors between 0 and 1 obtained from equation. Results. Table shows the results for optimal setting and sizing problems in distribution generation. PSO method is considered to compare with proposed algorithm results, as well as the position and digit size. Also, it is important to notice that the number of iteration and population have been considered equal to make it more comparable. Table 1 shows the overall real power loss of the system is decreased from 277 to 71 and 133 due to the installation of the two DGs by using GA and PS optimization methods respectively. Also, there is a huge difference between two methods to reduce the reactive power losses. According to the optimization results, the overall reactive power losses is decreased from 185 to 56 in GA method and 108 by using PSO method in table 2. Reactive and active power losses. These figures show actually a comparison between GA and PSO method, and also it shows that GA algorithm can more effective to reduce power losses. Voltage profile improvement. The voltage profile of per bus in a 33 bus distribution is depicted in the figure. The data indicate various voltage levels before and after DG installation. The results show different voltage levels during the installation of DG. For example, before installation of DG, voltage level of bus number 18 was 0.88. Actually, it was the lowest voltage in the system. But after installation, the voltage was improved to 0.95 in GA algorithm and 0.92 in PSO method. It is clear that voltage stability indexes for all buses in the radial distribution system were very poor before installing the DG. Objective indices results. The table shows the impacts of installation on reactive losses. Active losses and voltage deviation are depicted in the table, which shows the effects of DG installation on various distribution buses of the examined network. The derived indices from experiments that I mentioned in previous slides in the three aforementioned categories are used to evaluate these effects. The findings for the optimal allocation bus using the lowest objective function. As I mentioned in previous slides, as you can see in the table, the smallest WF connects to the largest value of objective. On the other side, the biggest value of WF, weight factor, connects to the smallest objective indices. As a result, it gives the equal chance to our objective. Also, in this table, GA has the better performance by comparing with PSO methods. The values of standard deviation in two algorithms used on the network are depicted in the diagram. Figure represents a comparison voltage deviation before and after installing multi-DGs by using optimization methods. GA performs better on the network than PSO, as shown in the figure. In this study, a comprehensive review of different methods used for DG optimal allocation. The advantage and disadvantage of algorithms were highlighted. It's also suggested the use of artificial intelligence methods to enhance voltage deviation as well as power losses. Using weight factors and stated parameter indices, this work presents a unique multi-objective optimization technique for simultaneous optimum allocation of multi-DGs. Moreover, active power losses, reactive power losses, and bus voltage deviation were all evaluated in the networks. To handle the radial distribution system, this study develops a forward-backward sweeping methods. Thank you for your attention. If you have any question, please feel free to ask.
Thank you for your presentation. Dear participants, do you have any question about the paper? Okay, no question. Thank you.
Thank you,
again.
sir.
I wish you success in your career.
Thank you, sir. Thank you for your attention.
The next paper belongs to dear Şeyma Mustafa Muhammed Al-Nafci. Are you ready to present?
Yes, sir, I'm ready.
Okay, you can share your screen and present.
Hello, my teacher and my friends. I hope you are well. I would like to welcome you at the beginning, and I hope that you will like my presentation of this thesis. Outlines introduction. Sorry, my thesis is about. I'm a little nervous.
You have 10 minutes, okay? You have 10 minutes, please.
Okay. My thesis is about design of electricity theft detection system based on supervised learning. Outlines introduction, research objective, related works, contribution, proposed system, results and conclusion. Introduction. 1. Power grid are critical assets not limited to the theft, distributing or defective meters and the arrangement of false meter readings of the structure faced with non-technical losses. NTLs in emergent markets. NTL is a main concern and up to 10% of the total distribution of electricity. 2. NTL's estimated annual global cost to utilities is around $100 billion. Therefore, is a crucial for utilities and authorities to reduce NTL to increase revenue, profit, and reliability of the grid. The result of electricity theft, broken electronic meters, or billing errors is non-technical losses, NTD in grids. 3. In this work, we present a novel framework called ETD, Electricity Theft Detection, which comprises of an intelligent algorithm such as ETD and SVM, RF, XGBoost, and neural network classifiers to detect fraudulent consumer from the normal consumer based upon the consumer consumption pattern. Research objective. 1. The global objective of this thesis is explore the capabilities of machine learning algorithm and SM data for NTL detection in electricity utilities. The goal of this algorithm is to detect any type of NTL regardless of its source, excluding NTL which comes from errors. The research is focused on two types of customers: industrial over large commercial contracted power greater than 15 kilowatt, and residential over small commercial contracted power less than 15 kilowatt. 2. The purpose of this research is to identify abnormal users with the machine learning algorithm, providing power enterprises with means to detect theft of electricity at lower cost. Related works. 1. Grid-oriented methodologies. Grid-oriented methodologies use energy balance, power flows, or state estimation to detect where NTL occurs. In 22. The authors propose a methodology for NTL detection at the MV-LV transformer level using distribution state estimation DSE. This methodology needs a single main measurement at the beginning of the distribution substation. 2. Hyper-oriented methodologies. Hyper-oriented methodologies use in the first stage network-related data to detect NTLs at the distribution transformer level or in several areas of the LV network. In 32. The author purpose and methodology for NTL detection using DSE and analyze of variance ANOVA. The DSA is used to detect distribution transformer with animals usage using the normalized residual test. 3. Data-oriented methodologies. Data-oriented methodologies area are very popular area of research for NTL detection due to their low data availability requirements. A methodology based on a SVM classifier has been proposed in 42, where the author used the model for classifying consumer as having or not having an NTL in their meter. Contribution. 1. The contribution of this study are listed as follows. 1. Purpose various features providing means to describe users' behavior. First, monistic features mean difference coefficient of variation, range, standard deviation. Binary features, cosine similarity, then principal component analysis is used to perform dimensionality education of the dataset. 2. Study various classification algorithm, optimize hyperparameter providing model to detect theft of electricity. In this study, the mechanism behind support vector machine, backpropagation neural network, random forest, and XGBoost is studied, and the hyperparameters are optimized. 3. Compare and evaluate different classifiers and provide suggestion for real-world application. In this study, different classifiers are evaluated with different metrics, and the best classifier is recommended based on the real-world dataset and different application scenarios. In this thesis, we will explore the capabilities of machine learning algorithm for NTL detection in the smart metering context, where electricity utilities have access to measurements provided by smart electricity meters. Proposed system 1, a model of electricity detection theft based upon supervised learning, is proposed as shown in figure below of this study. Inputs, processing, and output are included in the model. Diverse features and classification models are proposed in the processing segment, which the power companies recognize illegals and minimize operational costs. 2 features are proposed to describe user behavior. Dimensionality education is performed with principal component analysis, evaluation, metrics, and listed, and their meaning in the context of theft of electricity is discussed. 3. The study explore features extraction method and select the best performing algorithm and hyperparameters to detect electricity robbery and analyze the training for classifiers, namely backpropagate neural network, support vector machine, and random forest and XGBoost. Result. Random forest experiments are conducted to determine the optimal value of max depth, and in estimators max depth is the maximum depth limit for decision tree. When the value is too large, the complexity of the model and the risk of overfitting increase. When the value is too small, underfitting may occur. While we reduce the precision to find optimal limit for 3 different settings are tested. As shown by table and figure below, when max depth is set to none, no tree depth limit, best precision is achieved. Hence, none is selected for max depth as shown by figure below, with other hyperparameters remain unchanged. When n estimators exceed 10, the increasement in precision is small to save time, while maintaining precision 10 is selected for n estimators. In XGBoost, important hyperparameters include learning rate and an estimator for controlling the learning rate and number of iteration, max depth, min child weight, and gamma for controlling card growth, subsamples, and full sample by tree for controlling row and column sampling, and reg lambda for controlling regularization. Max depth limits the maximum depth for, of cards. Min child weight limits the minimum sum of instance weight in a leaf node. Gamma limits the minimum gain in the leaf node partition. Increasing min child weight gamma make the classifier more conservative, while increasing max depth makes the classifier more complex and more likely to overfit. To determine optimal value, a grade search is performed, and best value of max depth, min child weight, and gamma are found to be 9, 1, and 0, respectively, as shown in table and figure below. Finally, the conclusion. 1. In this research, methods for features extraction are analyzed. For classifier, including backpropagation, neural network, support vector machine, random forest, and XGBoost are analyzed and trained. 2. Then the best performing algorithm and hyperparameters are selected to detect thefts of electricity. The major achievements of this research are listed as follow. 1. Analyze features extraction and dimensionality education algorithms such as principal component analysis. 3. Process the original dataset and obtain 2 datasets, apply them to different algorithms, and analyze the influence different datasets had on the result to study various classifiers, analyze their principle and implementation. 4. Find the optimal hyperparameters, achieve a precision of 82.68% for backpropagation neural network, 86.88% for support vector machine, 98.05% for random forest, and 96.47% for XGBoost. Thank you.
Okay, thank you for your presentation.
Thank you, sir.
Dear participant, do you have any question about the paper? Okay, no question. Thank you again. I wish you success in your
Thank you,
study.
sir. Thank you, sir.
Dear Mohammed Hikmet El-Bazi,
Okay, sir. Hello.
okay, if you are ready, you can start your presentation.
Okay, sir. Hello, everyone, and welcome.
You have 10 minutes, please.
Okay. My presentation title: Control and Management of Microgrid-based Solar Charger using GOW algorithm.
You can share your screen. Do you have presentation?
Okay.
Okay.
My presentation: Control and Management of Microgrid-based Solar Charger use GOW algorithm. My name is Mohammed Hikmet El-Bazi. Outline introduction: how do microgrid work? Microgrid work components, the purpose and the IAM of this system. Advantage of using the GRAI of optimization GOW technique and conclusion. Introduction: a microgrid is a small-scale version of the national grid. It includes renewable power generation, distribution, and control. It is not a single home with the solar panel and the batteries. It's a system that includes power generation, the storage, distribution to multiple properties, and intelligent control for efficient energy use. A microgrid can be used to power multiple buildings or even in intervoltage. It will have sufficient power to provide it not all the energy requirement of those connected properties. And it can also be isolated from the national grid requirement, the microgrid to be fully sufficient for a time. How do microgrid work? A microgrid works the same way as the national grid, just without nuclear power station and plotting the landscape. A microgrid generated energy using renewable sources, usually solar panel. It stores that energy in battery bank for when it's needed. Those batteries and connected to control hardware that makes sure every property connected to the grid has the energy that they need. When they need it, each property connects to the microgrid in much the same way. You connect to the national grid through cables. Microgrids can be used as a solid energy source for an off-grid station or as a backup or clear alternative to the national grid. Properties can be connected to both grid and will be used on the intelligent controller to switch between the two. And as long as that there are sufficient generation sources and storage capacities, a microgrid could power connected property almost infinity. Microgrid components. A microgrid includes solar panel sufficient for damping and a wind turbine or backup generator for reliability, batteries sufficient to store the generated energy inverter, and the controller to deliver power to properties, connection and system to ensure the entire system works, and a switching to connecting the microgrid to the national grid. The purpose and the IAM of this system: number one, to maximize the efficiency of microgrids. Number two, intelligent energy management and battery sizing must be using the maximum renewable energy sources and minimize the conversion of in this complex systems. And number 3, the Gray-Wolf optimization GWO technique is presented in this article as a novel technique for meeting this requirement. Sorry. The purpose of the work is to present and analyze and approach for selecting the most ideal site for a hybrid photovoltaic wind system. The system integrated plant angle pitch control for wind turbines and PV farm voltage based maximum power point tracking for solar PV farms to maximize available output under a range of climatic situation. We will alter the predicted GWO in connection with the environment data. Advantage of using the Gray-Wolf optimization GWO technique. GWO proposing that the thesis is a more cost-effective alternative to standard mode method. Families save money by building a photovoltaic system. The GWO responses in and appropriate manner. For instance, that shows that it might be using to save spending, but it could also be using to alternative grid congestion among other things. Conclusion: the combined use of photovoltaic PV systems with the batteries and energy management systems (EMS) was explored to assess how much money may be saved to get the intended outcomes. GWO optimization for a 93 house neighborhood was used to simulate the EMS. The number of appliances and solar panel placed in each home were compared to the total number of appliances in the other houses. Additionally, the result of individual and pooled optimizations might be compared. In contrast to the other homes in the grid, each house has their own EMS, which enables it to monitor its own during the individual optimization process, rather than sharing the data the others. Thank you for your listening. Thank you, sir.
Thank you for your presentation. Dear participant, do you have any question about the paper? Okay, no questions. Thank you again. I wish you success.
Thank you, sir.
Dear Muhammad Kerim Muhammad.
Yes, I am safe partnered with Muhammad Karim.
Okay, you can start if you are
Yes.
ready.
Yes, okay.
Please, you have 10 minutes.
Okay. Okay. My presentation about SVC-based smart grid management of renewable energy resource. Abstract: a smart grid system can compensate for reactive power that changes in real time by using a TCLC compensator. When combined with the SVC, such as fixed capacitors, thyristor, controlled reactor factor, that generates low-order harmonic current TCLCs have the potential to be scientifically more effective than currently available static variable components. Considerations for reactive power compensation and harmonic current rejection are taken into account while generating the TCLC parameters in his research. The introduction. The energy sector is pursuing RES, which means renewable energy source, more aggressively in order to fulfill the rising worldwide demand for electricity. As an environmental economies develop, there is increased need for environmentally friendly and sustainable energy source. The International Energy Agency forced that worldwide energy compensation will grow by up 25% from present level by 2040. IEE, these three renewable energy sources are among the most technology advanced and ecologically benefit on the planet. Power electronic is an interdisciplinary field that spans many fields. It's been a century since the mercury rectifier was invented. Resolution in the field of power electronic extended into include a very varied of applications and disciplines. Energy works in the field of power electronic should have a breadth of experience. This includes power semiconductor device, converter circuits, electrical machines, and power system, and analog and digital control electronics, microprocessors and digital signal processes, FPGA and ACICS, application-specific integrated circuits. Semiconductors for applications requiring extremely high voltage extreme. Modern power electronic equipment relies heavily on power semiconductor device. Modern semiconductor devices have enabled power electronic converts to function at such as a high level of efficiency, near to percent that the year of commercial launch is shown in parentheses after the model number. Except for this, with a large band gap, all devices are silicon-based. While some devices have been decommented, their capability may still available via current technology. Applications of power electronics: increased affordability, the dependability, and flexibility of power electronics have led in every growing number of applications possible across a wide range of sectors, including industrial, commercial, military, and transportation. SMPS are often used to power a variety of electronic equipment, regardless of whether the power comes from an alternating current line or a direct current source. A UPS system is an example of alternating current controlled supply. Control and operation. Control and operation are distinct concepts. According to the others, consumers, suppliers, and network operators may all benefit from the optimal use of resources in microgrids, both financially and technologically. Carbon dioxide, CO2 emissions may be reduced by maximizing resource efficiency. A microgrid's advantage is the capacity to meet both electrical and thermal demands while efficiency and cost effectively using all available local resources, all while supporting environmentally friendly production and boost local dependability and power quality. This picture is about SVC-based microgrids, about distributable leads and microgrids. Advanced grid control. A mini or micro grid powered by alternating current, direct current, or hybrid energy is essentially a little power system that may run alone or in conjunction with a larger grid. Numerous issues exist in our current electrical system that impair these functions. The term power grid refers to an integrated system of electrical system that transmit energy to planets and predetermined frequency and voltage. Finally, the conclusion. The purpose of this work is to examine the creation, modeling, and assessment of TCLC compensations for dynamic reactive power in a three-phase, three-wire smart grid system. When developing TCLC parameters, the reactive power compensations range and harmonic current rejections analysis are taken into account. The suggested control techniques is based on the idea of generalized reactive power, GIRP. I'm finishing. Thank you for listening. Hello. Mister, can you listen to me? Can you hear me?
Okay, thank you for your presentation.
Okay.
Dear participant, do you have any question about the paper? Okay, no question. Thank you again. I wish you success in your career.
Thank you. Thank you.
Dear Muhammad Mehdi, are you ready to present? Dear Muhammad Mehdi?
Yes, I am here.
Okay. If
Good
you are
evening.
ready, you can start your presentation.
Okay, let me. I can't share my screen.
Okay, now you can share.
Yes, no. Good evening for everyone. My presentation for Gray Wolf optimization algorithm for integrated process planning and scheduling problem. Contents, we have introduction, then integrated process planning algorithm based approach, then optimization algorithms, then Gray Wolf optimization GW algorithm, then experimental result, then conclusion. Introduction. Market needs are increasingly barriers and
Please, you have 10 minutes, okay?
okay. Market needs are increasingly various and meet them. Some manufacturing firms have planned a high mixture of product manufacture with a few quantity strategy. A flexible manufacturing production arrangement seems a usual direction in manufacturing companies. The process planning modeled by computer implementation want to be more importantly essential. That because minimization the duration of fabricate design and minimize flexibility of the product life stages. The relationship between process planning and scheduling are overlapped. Integrated process planning and scheduling, the IPPS, recently take the center of attention in many academic studies. Outcome declare that IPPS, or integrated process planning and scheduling, may achieve the best utilization resources, so as minimization of cost, minimize production bottleneck, and enhance production system productivity, beside visible improvement in the manufacturing system performance. The IPPS treated as NP-hard problem, progression engaged, the integration become progressive and the increment of complexity to solve the algorithm. The optimum solution, to a huge extent, IPPS problem with the deterministic algorithm. Integrated process planning and scheduling, essential for optimum use of production resources and for the generation of realistic plans that can be readily executed with a little modification. The schema of the integrated process planning and scheduling, we have many projects, then a tree for every project, then a plan for each project, then the combination of these plans when using optimization algorithm lead to the optimal scheduling plan. And the IPP, integrated process planning is algorithm-based approach. The key activities of the algorithm-based approach initially, the process planning system generate multiple process plans, including overall jobs, and select a user-specified quantity of optimal plans obtained from the simulation data. The algorithm in the scheduling model is also used to determine scheduling plan for all jobs based on multiple process plans. Hence, the process plans for every job and also the scheduling times have been calculated based on the simulation results. Then optimization algorithms used in integrated process planning and scheduling. Finding solution of optimization ordinary is to achieve the optimal for the problem variable according to the problem objective, which are maximization or minimization for a number of problems. Objective function without violating the problem constraint. The typical optimization may have some obstacles such as cost of high computation, constrained with nonlinear finance, search environment with non-convex, objective function with dynamic to noisy behavior, and solution space for large problems. The essential criteria for choosing either an exact deterministic or approximate algorithm statistic to solve complicated real problem, even if the algorithm can offer the ideal global solution altogether. The results demonstrate exponentially increase similar to set variables. Sorry for this. Important criteria for selecting either exact deterministic or approximate statistic algorithm for helping solve real problems, even if a perfect algorithm is able to peer into all the interacts of the optimal solution. The amount of time is take exponential since it will need to recognize of all parameters. The Gray Wolf optimization algorithm. The Gray Wolf optimization try to emulate the hunting behavior of the family of Gray Wolf.
Dear Mohammed Mehdi, you can drink water. Okay, we
Okay.
climb.
It's just my snore.
Okay. You can get some rest.
Just 10 seconds. Sorry for this. Gray Wolf optimization algorithm. The Gray Wolf optimization tried to emulate the hunting behavior of family of gray wolves. Typically, gray wolves prefer to be a group. The group size of gray wolf range from 5 to 12 individual. They have rigid 4-level socially dominated hierarchy. I'll skip for this social hierarchy. We have a model the hierarchical system of wolves when concentrating gray wolf optimization. The alpha then present optimal solution. Therefore, second beta, then alpha, beta, gamma, then the omega will perform the remaining potential solution. As
Dear
shown in the figure.
Mohammed Mehdi, if you want, you can
Skip.
continue later.
I
End
will
of
finish.
the end of the session. if
We
you want.
have I have 4 slides or 6. Yani I will finish.
Okay.
Okay. The social hierarchy of Grey Wolf as shown in the figure. In cycling prey, as mentioned previously, Grey Wolf hunt and cycle their prey, then hunting or positioning updating. Updated the objective of automatic production control is to obtain the optimal control gain value. Then you have explanation and extrapolation. The wolf location modified toward the prey. If A bigger than 1 or smaller than -1, the omega plays the role develops. The optimal control of gain is determined by the wolf position update relative to its prey or optimal point. Figure 2 flowchart illustrates how update the location. Experimental result. We take 6 jobs with 3 process plan sets for each job with their processing time, and then applying using the Grey Wolf optimization. I will have the results as shown. We have the Gantt chart for the optimal solution and the relationship between fitness and iteration using Grey Wolf optimization. The final solution for each job with 90 minute duration of make span, which is better than the using data was used with another research. The conclusion, the experimental results indicate that Grey Wolf optimization is better in make span with some data used to increase efficiency of manufacturing system. So this research, the application of the introduce a technique to realistic manufacturing system is a future project. Future manufacturing system performance would likely to be enhanced by the increasing applying Grey Wolf optimization algorithm. Thank you for listening. Is there any question?
Thanks for your presentation. Dear participants, do you have any question about the paper? Okay, no questions. Thank you again. I wish you success in your career.
Thank you.
Get well soon. Take care of yourself.
Thank you. Thank you very much.
Next paper belong to dear Nasser Aldian Ambar Shaswa.
Yes, I with you. I'm with you.
Okay. Are you ready to present?
Yes, I'm ready.
Okay. You can start your presentation.
Yes.
You have 10 minutes, please.
Yes, I will do. Hello, good afternoon, everyone. The title of my article is Four-Stage Recursive Square Algorithm for Car Armor Systems, presented by Nasruddin Shasho. The presentation outlines our introduction for stage recursive identification algorithm, simulation result, finally conclusion. Section 1, introduction. The system identification is the main of building the system's mathematical models, and estimating of the system's parameters is the basis. Parameter estimation is significant for system identification and system modeling. Multi-stage least square identification algorithm is recently employed for estimating the parameters of versus systems model. The main contribution in this technique is to reduce the computational load. Low computational load in these algorithms achieve the better system performance. Section 2, four-stage recursive identification algorithm. In this work, linear time invariant system described by controlled autoregressive moving car armor is considered by this equation, where U is the input, Y is the output, V of K is the white noise with zero mean and variance sigma, and A, B, C, and D are polynomial are defined as these equations. Equation 1 can be written as this formula, where W of K is given by this matrix. The parameters vectors θ1, θ2, θ3, and θ4 are defined by this column vectors, and the information vectors phi1, phi2, phi3, and phi4 are defined as these matrices. Then the total output is given by this equation, where W of K is computed by this formula. Using equation 3 and equation 2 can be written as these equations. And now the total information vector can be given by this matrix, and the total parameter system parameters are given by this column vectors. Now the inner variable y1, y2, y3, and y4 are calculated by these equations. Then the system can be decomposed into 4 subsystems as this formula, where I equal 1, 2, 3, and 4. Now we calculate the estimate parameter every stage using recursive least square algorithm as this equations. The estimated parameter for every stage can be calculated by this equation. Li of k is computed by this formula. Finally, B of k is given by this equation. Estimated parameter theta 1, theta 2, theta 3, and theta 4 are computed by these equations. The unknown information vector phi 3 of k contains the unknown inner variable wk minus I, and q4 of k contain unknown inner variable phi k minus I. So the algorithm cannot be performed. Replacing w of k and phi of k with their estimate, and then estimated theta 3 and q3 and estimated q4 are written as these matrices. Now the total information vector is given by this matrix, and estimated W of k is computed by this equation, and estimated phi of k is calculated by this formula. Finally, for stage recursive least square algorithm for car ARMA is summarized as these equations. Section 3, simulation results. The effectiveness of four-stage recursive least square algorithm has been checked on sampling generated by the following car ARMA model as this formula. A, B, C, and D are given by these equations, and the total system parameters are given by this column vectors. QQ plot and estimation error have been used in order to evaluate the performance of the proposed algorithm. A QQ plot is plotted for residual generation for four-stage recursive least square algorithm that in blue color, and recursive generalized extended least square algorithm that in red color, which are tested in comparison with the standard normal distribution that in blue color as shown in figure 1. Here, blue one is the standard, black one, sorry, in standard normal distribution, blue one for stage, and the red one is generalized recursive least square algorithm. The figure offered that the result of the four-stage recursive least square algorithm much more closely along a standard normal distribution than the result of recursive generalized least square algorithm. This result indicates that the proposed algorithm is more effective than recursive generalized extended least square algorithm. Next, the four-stage recursive least square algorithm have been applied for estimating parameter and estimation error for the algorithm versus the time sequence from 0 to 3,500. Here in red one is generalized recursive square, and in green one, four-stage recursive identification algorithm. The figure demonstrates that the proposed algorithm can achieve more accurate estimate than recursive generalized extended least square algorithm. Finally, the estimated output and the true output of four-stage recursive least square algorithm are plotted in this figure. Here, the figure that black one, the true output, blue one is the estimated output. The figure demonstrates that the estimated output is close to the true output, which means the estimated model has high capability. Finally, conclusion. In this work, four-stage recursive identification algorithm is derived through assimilation results. It's shown that the proposed algorithm has some advantage in comparison with recursive generalized extended least square algorithm. Four-stage recursive least square algorithm improves the accuracy of estimated parameter and has higher computational efficiency than recursive generalized extended least square algorithm. The technique in this paper can be extended to multi-input single output and multi-input multi-output systems. Thank you for your attention.
Thank you for your presentation. The participant do have any question about the paper? Okay, no questions. Thank you again. I wish you success.
Thank you. Thank you,
Here's
sir.
Nasser. Okay.
Thank you. Thank you.
Dear Hamid Shimal Abdullaimi, Are you ready to present?
Good evening. I'm here, sir.
Okay. You can start your presentation.
Okay, tamam.
You have 10 minutes, please.
Okay. Thank you, sir. Is it clear my presentation on your screen?
Yes.
Okay, thank you. We have an article about vehicle speed advisory. It is a new technique for technique for safer and highway overtaking, presented by Hamid Shmal Abdulaimi from Iraq. I am a PhD student at Inetcom Sfax University in Tunisia, working in Ministry of Science and Technology in Iraq. With the supervisor, Professor Mr. Bassam bin Hamid. He's a professor in applied mathematics. First, we make a simulation for speed advisory system. The simulation was based on VANET. It is a vehicle ad hoc networks. This technique, suppose there is a vehicle-to-vehicle communication link based on IEEE standard 802.11 standard. This is a communication for vehicle-to-vehicle. From this point, we simulate 10 vehicles. Some of vehicles are set as semi-automated vehicles, SAV, on highway. This is a flowchart or decision tree for overtaking decision. See in clear? Yeah. For start, overtaking legal. Sorry. Is it overtaking legal? If yes, navigation needs, check navigation needs. If no, lane keeping, it's mean LK, it's lane keeping, stay on the same lane. If yes, navigation needs, I mean, it's if you have to turn left or right, so you can change the lane. If yes, is it suitable gap? It's distance between two vehicles. If yes, you can lane change. If no, you can still at the same lane until you have the suitable gap. So in the other branch, if no, there is no navigation needs, but we have to overtaking. We check for vehicle velocity. If the velocity is greater than the behind or sort of the in front vehicle, if yes, you can change lane, or no, you can still in the same lane. It means lane keeping. Well, if yes, there is you can change. You can test for if your velocity is greater than the V lane. You know, at highways, each lane have a limit for high velocity. If your velocity is greater than V lane, you can suitable for gap and lane change. Or if no, you can stop, wait for suitable gap and lane change, overtaking, and assume to original lane. It means if you have traveling or moving on the middle lane, and you have a velocity greater than the velocity of middle lane, you must change your lane to the left lane. or if you have the same or the same limit of velocity and middle lane, but there is a vehicle front you with a slow velocity, you can change your lane, and finally you can resume to the original lane. This is the inter-safety distance calculation. Here we have a speed sensor for vehicle 2. It is the concerned vehicle, where we have to get a road condition. It means what is the condition of road is there is a curvature, there is a slope in the road, or there is works on the road. Any condition on the road, we have to take this information. Then we have DSRC, TXRX. This is the information of the neighbors' vehicles for velocity and position and acceleration and another information. So here we have distance counter, and then we have the distance between vehicle A and vehicle B. Then they have decision if there is a short distance, we have to get warning, or it is safe to continuous in the same lane. This is the overtaking safety distance. We implement this scenario in simulator. We suppose there is two vehicles on the same lane, and there is coming behind another vehicle, the third vehicle, on the middle lane. And when we have to calculate these parameters for overtaking safety distance and inter distance between every vehicles, and then to get the decision if you can make a overtaking with the right or a suitable acceleration. This is the This is the proposed algorithm or approach. It is a vehicle optimal speed advisory. When you calculate your velocity with respect to other velocities, the system will advise you with the suitable velocity, and if it's allowed or not allowed or forbidden for overtaking at this time, and the speed you must to travel on to make overtaking, and the time required. The time required, it depends on your speed and the other vehicle speed and the distance between each vehicles. So you can have this advice every 0.2 seconds. We have to transmit this information or calculate this information and transmit it to the driver every 0.2 seconds. That is mainly this real time on highway. This advice or the speed advisory will help the drivers to make this right decision at the right time and at the right position on the highway to make overtaking or not. Let us see the simulation. We have first obstacle we simulate in the traffic accident between two vehicles in order to force another vehicle to make overtaking maneuver. Here there is an accident between two vehicles, and there is a vehicle coming behind. When there is accident, the vehicle come behind, make a decision to overtaking, and then change lane from the right to the middle lane and to overtake the accident. The second obstacle we have to simulate this emergency vehicle coming from behind is the second obstacle that we simulate in order to facing the other vehicles to make overtaking maneuver to clear the left lane. This is the obstacle emergency. You see, it's a high speed on the left lane. And when it's coming from behind the vehicle, other vehicles will clear the left, automatically clear the left lane to make it clear for emergency car or vehicle. In this scenario, we have to make overtaking here. You know, this car make to overtake this obstacle, and then we take the next slide for the speed advisory function activation. This is the proposed function for semi-active, semi-autonomous vehicles. We can see here, this is the function. When there is two aligned vehicles, it's not allowed. But when is the clearance, okay, it's we allowed. Overtake and then return to its original lane. And also for this vehicle, you know, this is it's now allowed for overtaking, but when this vehicle comes near to this vehicle, it will be not allowed, as you see. And when it's passed, it will return to be allowed for overtaking. The same things was for the vehicles in front of the emergency vehicle at left lane. You can see this part of simulation. This car with a flag, it is the concerned vehicle. When the emergency coming behind, it's not allowed, but when the emergency goes away, this way it will be allowed for overtaking. The result obtained from the simulation analysis show general utility for the overtaking based on safety criteria. We must take in consideration the following. The overtaking velocity greater than overtaking vehicle velocity at least by 15%. The overtaking acceleration must be within limit not greater than 4 meters per second square, or overtaking vehicle the acceleration not greater than 5 meters per second square. The overtaking velocity within the limit of maximum lane speed, the minimum gapping between position A and B prior overtaking. For rainy, fog, dusty, windy weather, the overtaking must be 50 to 20% less than the road speed limits. A cloud connection is very important to obtain navigation data for right decision for overtaking. Thank you for attention.
Thank you for your presentation. Dear participants, do you have any question the article? About the article?